A spherical symmetric charge distribution is characterized by charge density having the following variation: rho r rho naught 1 minus r by r for r lesser than r, rho r equals to 0 for r greater than equals to r. So for r greater than r, there is no charge density, so charge density is up to radius r1. Now we have to find electric field at some internal point of r less than r here. So this is our sphere of radius r, and in that we are going to assume a spherical shell of thickness dr over here. So this is our sphere of radius r, and in that we are going to assume a spherical shell of radius r and thickness how much? dr. So here we will try to calculate the charge that is present on this spherical strip. So let us consider a spherical shell of thickness dr and radius r. So if I write dV, the volume of this strip, why I am writing dV here? Because rho is given now. So in this small r2 dr, we can assume rho to be constant, and so we can calculate the charge on this strip, and then we can integrate. So dV I will be writing it as a 4 pi r square dr, and we got dV, so we can calculate the value of dq here. So dq will be surface charge density into 4 pi r square dr. So if I calculate total q enclosed in the green region, then q enclosed will be dq, and if I substitute the value of dq here, then this dq is rho into 4 pi r square dr. Now we will substitute this value here. So rho is basically rho naught 1 minus r by r 4 pi r square dr. So we will get the value of charge enclosed from 0 to r here, and then for electric field I will write E equals to how much? That will be K Q enclosed by r square. So that's a simple approach we have to do. Now follow the calculation part here. So if I substitute the value here, if I simplify it, so first of all I will take the constant out of the integration, so rho naught and 4 pi. So 4 pi rho naught is a constant which can be taken out, and in the inter part we have r square dr ranging from 0 to r minus this will be r cube dr by r, and that is 0 to r again. Now let us calculate this value. So this will become 4 pi rho naught r cube by 3 minus this will be r4 by 4r. So this is our q enclosed that we have got here. Now we need to substitute the values of q enclosed over here to get the value of E. So E I will be writing K, that can be written as 1 upon 4 pi epsilon naught, and then q enclosed I will substitute here as 4 pi rho naught, and this is r cube by 3 minus r4 by 4r divided by r square. So you can see 4 pi and 4 pi will cancel, and in the last the result that we will get here, E will be rho naught by epsilon naught, and this will become r square, and r cube will give you r by 3, r square and r4 will give you r square by 4r. So this is the answer to our given problem.